This episode of The Deep Dive is brought to you by Wadadli Solar LLC, making sure your solar investment actually pays you back.
Welcome back to the deep dive. I was sitting in a coffee shop the other day, just watching everyone on their laptops, and I had this realization.
Oh, yeah.
We are all just renting, aren't we?
Renting what? Apartments?
Well, that too. But I mean our brains. Our digital brains. You open your laptop, you log into some cloud service, you ask an AI a question. You're essentially leasing intelligence from a server farm in, I don't know, the middle of nowhere.
That is a very specific and slightly terrifying way to look at it.
Yeah.
But you're not wrong.
Yeah.
We've become tenants in our own digital lives.
Exactly. And that is why today's deep dive is so exciting. We're looking at a source that challenges that entire tenant mindset. We're stripping away all the marketing, no magic, no neural clouds, and just looking at the nuts and bolts of how you build your own intelligence.
We're going to get our hands dirty today. The source material is a really fascinating technical journey. It's titled, What Does Your AI Stack Look Like? From Tandy 2000 to local LLMs.
And the mission here, to figure out how to stop leasing and start owning. To explore what it looks like to build a local AI workstation right now, today, in 2026.
And what I love about this source is the perspective. This isn't some futurist, predicting the singularity in 20 years. The author is an IT veteran.
Right.
They started their journey back in the 1980s with a Tandy 2000 and have been in the trenches, fixing printers, managing networks, writing code since '92.
The Tandy 2000. Okay, for the listeners who didn't grow up with floppy disks the size of a dinner plate, can we just set the scene? What was using a computer like back then?
It was raw. I mean, there was no mouse to click, no windows to drag around.
Just a blinking cursor?
A blinking cursor on the green screen. That was it. If you wanted the computer to do something, you didn't ask it nicely, you commanded it, you wrote the code, line by painful line.
There was zero abstraction. You were the ghost in the machine.
Precisely. And the author uses that history to make a really crucial point about AI today. We tend to think of artificial intelligence as this new alien magic that just appeared overnight.
Yeah, that it just popped into existence.
But the author argues that AI is not magic. It is architecture.
It's just engineering.
It's the assembly of familiar components, things we've used for decades, just arranged in a way that creates something called compute density.
Okay, let's prove that. The source actually lists out the components of that old Tandy 2000 and compares them to a modern AI rig. And it's kind of shocking how similar the lists are.
It's the same ingredients, just a different recipe. You've got the motherboard, the CPU, the RAM storage, power supply.
The basics.
These have been the staples of computing for 40 years. Whether it's a Tandy or a supercomputer, those parts are there.
It's like comparing a Ford Model T to a Formula One car. They both have wheels, an engine, a steering wheel, a chassis.
Exactly. But if you look under the hood, the engine works very, very differently. And that brings us to the new element, the one component that didn't really exist in the Tandy days, at least not in the way we use it now.
The GPU, the graphics processing unit.
This is the game changer.
And this is the part that always makes me laugh. We didn't invent GPUs to build artificial brains. We invented them so teenagers could play video games, right?
Pretty much.
I remember needing a new graphics card just so the explosions in Crysis looked realistic.
That is literally the origin story of the modern AI revolution. It turns out that the math required to render a realistic explosion, calculating the trajectory of thousands of little particles, the lighting, the shadows, all at the exact same millisecond.
Yeah.
It's the exact same type of math required to run a neural network.
So wait, we accidentally built the hardware for AI while trying to get better frame rates in Call of Duty?
Essentially, yes. A traditional CPU, the main processor, it's like a really smart manager. It does complex tasks one by one very fast.
Okay.
But a GPU is like an army of thousands of workers. They aren't as smart individually, but they can all do a simple math problem at the exact same time. That parallel processing. Yeah. That's what AI needs.
So the shift isn't that we reinvented the computer. It's that we added this massive density of parallel compute power with the GPU and then just layered the right software on top.
Correct. We took standard PC architecture and gave it a turbocharger specifically designed for matrix multiplication.
Okay, so we've established the theory. AI is just dense computing. Now let's get to the fun part, the gear.
To build.
It's Saturday, February 7, 2026. The author lays out the specific anatomy of a machine capable of running local AI today. And I want to emphasize, this isn't some theoretical $1 million server rack.
No, not at all.
This is a build you could put on your desk.
It's a high-end consumer build. It's attainable.
Let's walk through the specs because every choice here tells a story. We start with the foundation, the motherboard. The author chose the Asus 2 Gaming X870 Plus.
That's an AMD board. And notice the gaming branding again.
Right.
It's consumer hardware. But the key here is durability and connectivity. When you're moving massive data sets, gigabytes of information between your storage and your processors, you need a board with really fast lanes.
And plugged into that board is the brain, the AMD Ryzen 9 7900X.
Now, this is interesting. We just said the GPU does all the AI work. So why do we need such a beast of a CPU? The 7900X has 12 cores and 24 threads.
Yeah, isn't that a little bit of overkill?
Not for this kind of setup.
Yeah.
Remember, we're not just running a chatbot. We're building a local stack.
Ah, right.
That means running virtual machines, background services, databases. You need those 24 threads to juggle all the different tasks while the GPU focuses on the thinking.
Got it. The CPU is the conductor of the orchestra. Okay, next up, memory. 32 gigabytes of DDR5 RAM.
This is pretty much the bare minimum for a serious build in 2026. Speed matters, DDR5 is blazing fast, but capacity is the real bottleneck. Everything your computer is doing lives in RAM. If you run out, everything just stops.
And keeping this whole orchestra from overheating is the cooling system. The author uses the Be Quiet Dark Rock Elite.
I love that brand name. It's a command. Be quiet.
It really is.
But silence is a functional requirement here. If you're going to have this machine on your desk running an AI model that might take 10 minutes to analyze a document, you do not want it sounding like a jet engine taking off.
No.
You need thermal mass.
Okay, now I get to the star of the show, the engine, the GPU. The author's running an NVIDIA GeForce RTX 5060 Ti.
This is the most critical component, and I can just hear some of the hardcore enthusiasts screaming, why only a 5060 Ti? Why not the 5090?
Yeah, I was thinking that. Isn't bigger always better?
In performance, yes. In wallet impact, no. The 5060 Ti represents the value tier. But the most important number here isn't the model number, it's the VRAM, the video memory.
Okay, explain that distinction. Why does the video card need its own memory?
Think of VRAM as the workspace that's directly attached to the GPU. When you want to run a large language model like Llama 3 or Mistral, you have to load the entire brain of that model into the VRAM.
The whole thing.
The whole thing. So if the model is 12 gigabytes and your card only has 8 gigabytes of VRAM, it won't fit.
It's like trying to fit a dictionary into a wallet.
Exactly. The 5060 Ti is that sweet spot where you get enough VRAM to run these really capable open source models without spending the price of a used car.
We interrupt this podcast with a quick reminder. Solar systems that aren't inspected don't perform as designed. Annual inspections protect output, safety, and payback. Wadadli Solar LLC, serving the U.S. Antigua, Guyana.
So we've got the hardware, it's assembled, it's quiet, it's powerful. Now we have to wake it up. The operating system is Windows 11 Pro.
But there's a twist.
There's always a twist with these tech builds.
It's Windows on the surface, but underneath, the author's using something called WSL2 Windows Subsystem for Linux plus Docker, running Ubuntu Linux.
Okay, pause. I can hear the non-technical listeners reaching for the skip button right now. Why are we making this so complicated? Why not just download an app and double-click it?
Because the native language of artificial intelligence is Linux. All the cutting-edge research, from Google, from OpenAI, from the open source community, it's all built on Linux first.
So if you want the good stuff, you have to speak the language.
Right. But we all use Windows for our email and our games.
Yeah.
So WSL2 is kind of like a diplomatic treaty. It lets you run a full professional Linux server inside your Windows desktop. And Docker. Think of Docker as shipping containers.
Okay.
It keeps all that messy, complex AI software contained in these neat little boxes so it doesn't break your main computer.
So it's a hybrid approach. It's kind of like the mullet stack.
Oh, what now?
The mullet stack, business in the front windows for your spreadsheets and games.
I see where this is going.
And a party in the back, a full Linux AI server.
The mullet stack. I love it. I'm absolutely stealing that. But yeah, you're not wrong. That is exactly what it is. It gives you the best of both worlds.
So we have the mullet stack running. Now the million-dollar question. What does this thing actually do? Because the author isn't just generating funny poems or asking for cookie recipes. They're talking about replacing the cloud.
This is the aha moment. This is where we move from playing with tech to owning your digital life. The author lists specific applications that replace the subscription services we all pay for.
Okay, let's run through them. First up is Image.
Image is a powerhouse. It is a direct replacement for, say, Google Photos or Company Cam. You know how you can search your Google Photos for dog on a beach? And it magically finds it?
Yeah, it's incredible.
It's not magic, it's AI. And right now, Google is doing that processing on their servers, scanning your family photos to train their models or target ads. Image does the exact same thing. Facial recognition, object detection, smart search, but it uses your RTX 5060 Ti to do the scanning.
So the photos never leave your hard drive.
Never. The AI runs locally. You get all the convenience without the surveillance.
That is huge. Okay, next on the list is Invoice Ninja. Sounds like a video game, but it's actually for business.
Yeah, it replaces services like Bill.com. It's a full financial suite invoicing, payments, quotes. Again, just think about the data. Do you want your client list and financial details on a public cloud server that might get breached, or do you want it encrypted on your own machine?
Good point. Then we have Espo CRM. This is replacing HubSpot.
And anyone who runs a business knows HubSpot is expensive. We're talking hundreds, sometimes thousands of dollars a month. Espo CRM handles your customer relationships locally. No monthly fees, total control of your customer data.
And for the note takers out there, Obsidian as a long-term knowledge repository.
Obsidian's great because it stores everything as plain text files, markdown files. So if the company behind Obsidian goes bankrupt tomorrow, you don't lose your notes. You just open the text files in Notepad. It's future-proof.
But here's the kicker. Those are the apps. How do we actually talk to the AI? The author mentions two specific tools, LM Studio and Open Web UI.
Right, this is a point of confusion for a lot of people, so let's clear it up. LM Studio is like the engine mechanic. It's the software that lets you browse, download, and actually load these large language models onto your GPU. It manages the hardware side.
Okay, so that's the back end. What's Open Web UI?
That's the face. It's the interface. When you install Open Web UI, it looks exactly like ChatGPT, identical. You have the chat history on the left, the text box at the bottom. You type, "Write me a marketing plan."
And when I hit enter,
When you hit enter, instead of sending that request to California to be processed by OpenAI, it sends it to the Docker container on your machine, which sends it to LM Studio, which runs it on your RTX 5060 Ti.
and the text just appears on the screen.
Just like magic. But it's your magic.
That is a wild concept to really sit with. You've cloned the experience of the cloud, but you've cut the cord.
Oh.
But I have to play devil's advocate here.
Please do.
This sounds like a lot of work. I mean, buying parts, building a PC, learning Linux commands, configuring Docker, versus just paying $20 a month for ChatGPT to handle it for me. Why bother?
That is the ultimate question, isn't it? Is the juice worth the squeeze? The author, speaking with that network admin mindset, gives 4 specific reasons. And honestly, they're hard to argue with.
Let's hear them.
Reason number 1, redundancy. Systems should work when the internet doesn't.
Oh, we've all been there. The internet cable gets cut or the Wi-Fi acts up, and suddenly you are dead in the water. You can't work.
In this setup, you are an island. The internet can go dark, the world can disconnect, and your AI, your invoices, your CRM, they all just keep humming. You have total operational continuity.
Okay, reason number 2 is probably the one that resonates most with me. Research control.
Or as the author puts it, privacy by physics.
Privacy by physics. That is such a strong line.
It's the only real guarantee. If you type a trade secret or a personal journal entry or sensitive medical data into a cloud model, you are trusting a terms of service agreement. You're just hoping they don't look at it.
Right.
When you run it locally, the data physically cannot leave your GPU. It processes the tokens and discards them. It's a black hole.
You can't leak what doesn't leave the room.
Exactly.
Reason number 3, cost savings. The author calls it the per-token ransom.
It's a great phrase. Cloud AI charges you by the token, basically by the word. The more you use it, the more you pay. Or they hook you on a subscription that just creeps up every year.
And the local build is a capital expense. You pay once for the hardware, and then it's yours.
You pay for the hardware and the electricity. That's it. You just step out of the subscription economy.
And finally, operational independence, no vendor lock-in.
We see this all the time. A startup gets bought, they shut down a feature you rely on, or they change the pricing model overnight. If you're renting your intelligence, you're at the mercy of the landlord.
What, when you build the stack?
You are the landlord. You own the platform.
But the author is honest, too. They admit this isn't free.
No. You pay with time. You pay with effort. When a Docker container crashes at 11 p.m., there is no support chat to open. You are the support team. You have to fix it.
It requires a certain kind of person. You have to be willing to be a mechanic, not just a driver.
But the payoff, as the author describes it, is this feeling of resilience. It changes how you think about technology. You stop being a passive consumer, a user, and you become an active operator.
It really brings it full circle back to the Tandy 2000, doesn't it?
It does. We've gone through this long era of user-friendly design where everything was hidden behind shiny buttons and clouds. And now, with local AI, we're seeing a return to that power user ethos, the idea that I built this, I own this, I control this.
So we've tracked the journey from the, beige plastic chassis of the 1980s to the brushed aluminum and RGB lighting of the 2026 local stack. We've seen how the components stayed the same, but the density changed everything.
And we've seen that the choice is real. You don't have to rent your brain.
As we wrap up, I want to pose the author's closing questions directly to you, the listener, because they really made me stop and think.
It's a challenge, really.
It is. The author asks, how is your AI stack coming along?
Are you still leasing intelligence from subscriptions? Are you paying that monthly rent for the privilege of thinking?
Or are you ready to go full nerd, grab a screwdriver, and build it yourself?
It's a serious question. And I'll leave you with one more thought to mull over.
Okay.
Once you build your own platform,
Mm-hmm.
once you experience that speed, that absolute privacy, that feeling of ownership, is it even possible to go back to the cloud?
I don't know if I could.
I don't think so. Once you taste that independence, the cloud starts to feel a lot like a cage.
A gilded cage? Maybe, but a cage nonetheless. Something to chew on while you check your bank statement for all those $20 subscriptions. That's it for this deep dive. Go check your specs, and we'll see you next time.
Thank you for listening to this podcast. We hope you found this podcast useful. If you have any questions or comments, feel free to reach out to us at info@alternativesolutions.ag. Thanks again for listening and be sure to tune in for future episodes.